Okay, we talked about how to draw forces, and now I like to tell you about um, resistant forces. Resistant forces are very interesting. Resistant forces appear only if an attack happens. So they are passive. They're never aggressive. They only appear to cancel an attack from another force. So, for example, of course, friction is one of those. As you can see in here, imagine there is a box here. You pull it with 1 Newton. So the force equals 1 Newton, and the friction will appear only 1 Newton just to cancel this. So if a friction appears only 1 Newton. So now imagine you increase the force, you make it 3 Newtons, and the friction appears 3 Newtons. 3 Newtons. In here it was 1 Newtons, and in here 3 Newtons. So now imagine that you make it much bigger. So you this time apply a force of, let's say, 5 Newtons. If 5 Newtons, and imagine that your friction cannot resist more than 4. The maximum force friction can create is going to be 4. The friction appears 4, which is its maximum. So of course in that case this is the real picture. Actually the total force would be F total, let's say, actually let's write it here. F total would be, of course, 4 minus 5 minus 4. 5 is bigger, 5 minus 4, which is 1. So of course if you want to draw your picture in here, this would be the actual force, which is the total force, which equals to F total, which equals to 1 Newton, right? So you know this in here. Now I'm going to introduce another resistance force, which is called normal force. I don't know why it's called normal, because it is actually the resistance of the surface. So I call it resistance of the surface. Let's say you have a surface here. Of course this is your box, and the center of the earth, imagine, is brown. Okay, the brown center of the earth applies gravity to this force, which equals to the m of this box actually. So the m of the box with the g, which is this is mg. This is actually the weight of this box applied to it from the earth. Now the surface of the earth actually applies the resistance of the surface, because if it does not, the box is going to get inside, breaks up the surface and gets inside. So this resistance of the surface appears exactly equal to this mg. So for example, if this mg equals 1, this also would be 1. So now imagine you, this can be a surface of anything, surface of table, or surface of any kind of surface. So you increase the, actually I'm gonna to make it quick, stop using colors for now, but you know what I mean. So I put a heavier box. Let's say this time the mg is 3, and of course the n will appear exactly 3. The resistance of the surface would be also 3. So imagine you make it bigger now. You put a heavier box, which is 5 Newtons. mg equals 5, and the n cannot appear 5. The maximum n possible would be 4. So in that case the resistance of the surface maximum can be 4, and therefore the surface is gonna break, it's gonna crash, and the box is gonna get inside. So of course then the force applied to such a box would be the total force equals 5 minus 4. So the total force would be 1 in here, which is taking the box inside.